So this is a run through for the B3C3P3 Foundation Paper 2. Make sure you've done the first one before you start this one. And remember, you've always got this list of equations to help you specifically with the physics section, but the chemistry section also you might need this top one as well. But first is the biology section. So the question is, Louise investigates how exercise affects her pulse rate. She runs around the school field as fast as she can. She then sits down and measures the pulse rate every minute for 10 minutes, and the table shows her results. There they are. What is Louise's resting pulse rate? So you can see at the bottom here that you've got the same pulse rate in two in a row, and that will be her resting pulse rate because it's not going to go any lower than that because it's already stopped going further down. So 60 is the answer there. And then how can you tell this from Louise's results? So it's because it levels off. So anything to do with it levelling off will get you that mark. Next question, what is Louise's recovery time? So you can see from the table that actually it hits 60 after 6 minutes. So the recovery time is 6 minutes. And how you can tell this? Because the time taken, that's the time it took to return to the resting value. So this is the time taken to reach 60 beats per minute, which was the resting value. Or you could say it's the time taken to return to normal. Explain why Louise's pulse rate decreases after exercise. So you can say, well, any three from these, so you can say that less energy is needed because she's not exercising anymore. You could say that less respiration is needed, so that's a second mark. You could say that less oxygen or glucose is needed by the muscles, and that's 2 marks there. So less oxygen is needed for 1 mark, and by the muscles for a second mark. So any 3 of those 4 things would get you the marks there. Next question. Bob has a garden centre. He grows plants called pelargoniums by taking cuttings. If there's ever a question where you've got a long word like this that you're not quite sure what it means or how to pronounce it, don't worry. You can see that it's just a plant and it's not going to affect the rest of the question. So it says, describe how to take a cutting to grow a new plant. So the first mark is for saying that you remove a shoot or a branch. You don't have to put both of those, it's either or, shoot or branch. You could also say cut the stem or take a leaf cutting, and then you'd say that you plant that in soil. Next question. Write down one disadvantage of growing new plants by taking cuttings compared to growing them from seeds. So the main idea here is that if the original plant was susceptible to a disease or it was likely to get a disease, then the new plant will as well because they're genetically identical. So you can either say there's a lack of variation between the plants, or you could say that if one would get a disease, then all of them will as well. Next one, the diagram shows a cell from one of those plant's leaves. Describe the function of the vacuole. So it contains sap, so that'd be your mark, that'd be your first mark. And then you could then say it provides support. So there's 1 mark for each of those. The way that plants grow is different from the way animals grow. Describe how plant growth is different. So the difference is that plants grow continuously, whereas animals grow early in their life and then stop growing, and that plants grow only in specific parts, but in animals all parts of the animal grows. So those are your 2 marks there. So first mark, that plants keep growing continuously, whereas animals grow only in their early stages of their life. And then in the second mark, saying the plants grow in specific parts, but all parts of the animal grows. Next question. The diagram shows a sperm cell and egg cell. They are not to the same scale. So that means that if an egg cell was this big, the sperm cell wouldn't be this big. Actually, an egg cell is far bigger than a sperm cell. So name the parts labelled X on the sperm cell. So those parts are called the mitochondria. If you don't spell this right, at least the examiner at least needs to be able to see that that's what you meant. And then women usually release 1 egg cell each month. Men produce about 100 million sperm cells each day. Why is it important that more sperm cells and egg cells are produced? And that's merely to increase the chance of fertilization, because you could put that many sperm cells would die or many sperm cells don't reach the egg, or you could say that at least one of them will get to the egg. So the idea that just increases the chance of a sperm cell getting to the egg. Although women usually release one egg each month, other females often release many more. One female codfish may release 5 million eggs at the same time to the sea, just why fish need to release many more eggs than humans. And that's just it, because there's a less chance of one egg being fertilised, or it just increases the chances of fertilisation. So the same answer to question B, really. So it's just increasing the chances of fertilisation. Or you could say that they may have got eaten by a predator in the sea. There's not really any parental care there. Next, cod egg cells contain 23 chromosomes. How many chromosomes will there be in each body cells? Remember that the egg cells or sperm cells contain half the number of chromosomes as a body cell. So a body cell is going to contain 46 chromosomes if the egg cell contains 23. So the next question is a 6-mark question. Can you look this up for yourself in the mark scheme or online on the Google site? If you are unsure whether you've marked it correctly, then please ask your teacher to have a check of it. And now we're on to the chemistry section. So first question in the chemistry section, antacid tablets are used to stop indigestion. Jenny and Gary investigate 2 different antacid tablets, X and Y. Both tablets, X and Y, contain only calcium carbonate and magnesium hydroxide. Calcium carbonate reacts with hydrochloric acid, and calcium chloride, water and carbon dioxide are made. Write a word equation for this reaction. So as I've said before, you should always get these word equation marks, because all you need to do is put an arrow in the middle and then write what's reacting together on the left hand side and what is being made on the right hand side. So it tells you what's reacting together, calcium carbonate and hydrochloric acid. So you put those on the left hand side with a plus in the middle of them. And on the right hand side just put what's made. So it tells you that calcium chloride plus water plus carbon dioxide is made. So that'll get you 1 mark. Then look at the diagram. It shows the apparatus they use for this reaction. It says Jenny and Gary react tablet X with 100 centimetres cubed of hydrochloric acid. They measure the volume of gas made during the first 5 minutes. They do a second experiment using table Y and 100 centimetres cubed of hydrochloric acid. Look at the table, it shows the results. So you can see how much carbon dioxide, or the gas it says here, but from your formula that you wrote earlier you can see it's carbon dioxide, how much is made over the time. And then it's drawn a graph, says what is the volume of gas made at the end of the experiment. So if you look at the graph, the end of the experiment, well, that's where the end of the experiment is, and so that's 48 centimetres cubed if you read across where the straight line is. And it says, why does the reaction stop? So any reaction stops just because the reactants have run out. So you could either say that all the reactant is used up, or you could say that the hydrochloric acid is used up, or you could say that the calcium carbonate is used up, or all the tablet is used up. Any of those will get you the mark. Just the idea that what's reacting together, one of them or both of them have been used up. Once one has run out, the reaction will stop. And then it says plot the results for tablet Y on the graph. Draw the best curve through the points. So you've got to make sure that you plot in the right places. So your first one should be at 1 minute and 32, which is here. And then second one, so 2 minutes is at 55. And then 3 minutes at 68. And then 4 minutes at 72. And 5 minutes 72. Then you just need to draw a smooth curve through all the points, like so. So you get 1 mark for making sure all the points are plotted, and 1 mark for drawing a line of best fit. But make sure you don't do a dot to dot. So these aren't straight, these lines. It curves around. You can see that. So it doesn't go dip, 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 dip. It curves around them. Tablet X contains less calcium carbonate than tablet Y. How do the results show this? Well, you know that there's less calcium carbonate because there's less gas made. So the results show because at the end there's less gas made. The more gas made means there's more calcium carbonate in the tablet. The rate of reaction between calcium carbonate and hydrochloric acid can be sped up. One method is by using a more concentrated solution of hydrochloric acid. Write down and explain using the reactant particle model 2 other ways that the reaction could be sped up. So this is worth 4 marks. So they've told you that you can use a more concentrated solution. So the other 2 ways is don't just write temperature. You've got to say how to increase the reaction rate. So you need to put increase temperature, and there you can say that the particles move faster or the particles have more energy. And therefore there's going to be more frequent collisions. You could say increase surface area, and that would mean more frequent collisions. So you could also say there that you could turn the calcium carbonate into a powder, or you could say you could use a catalyst. Or you could say that you could stir or shake it, and that would make more frequent collisions as well. So any of those points, these are the main ones really that you could be getting. So 1 mark there, 1 mark there, 1 mark there, 1 mark there. But you could also say for mark stir or shake it, and that is more collisions, or use a catalyst, that would get a mark as well. Fertilizers and medicines are useful chemicals. Ammonium sulfate is used as a fertilizer. Ammonium sulfate is made by reacting ammonia with dilute sulfuric acid. The ammonia needed for this reaction is made a continuous process. This is different to the batch process used to make most medicines. A continuous process is used to make ammonia, but a batch process is used to make most medicines. Explain why. So there are 2 marks here. So the first mark is saying that ammonia is needed in large amounts. So lots of ammonia is needed, you could put. And then the second mark is for saying, well, why the drugs use a batch process. So medicines are made on small scale, or you could say that it's easy to switch between making different drugs in the batch process, or you could say that drugs are needed in small amounts. So you could say that ammonia is needed in large amounts and drugs are needed in small amounts. Next question, how do scientists check that medicines are pure? So to check purity, you use chromatography. So there's your answer there. Then Alex makes an ammonium sulfate in a laboratory. Look at the diagrams, they show the method he uses. There it is. Alex predicts he should make 8 grams of ammonium sulfate. He actually makes 6. It says, show by calculation that his percentage yield of ammonium sulfate is 75%. So here, to work out percentage yield, you do the actual yield divided by the predicted yield, and then turn to percentage times by 100. So it would be 6 divided by 8 times 100, and that equals 75%. So that will get you 2 marks, just showing the calculation to get to 75%. Suggest why I didn't get 100% yields. There's lots of different ways you might not get 100% yield. So the main one here is the loss where liquids are being transferred, like here and here. But you also might get loss when it's being heated, so loss in heating or loss in evaporation. So 3 different points there you could make to get them 1 mark. So loss in evaporation, loss in heating, or loss in transferring liquids. Any one of those. Next question. Alex decides to make another fertilizer called sodium nitrate. He reacts sodium hydroxide with nitric acid, and sodium nitrate and water are made. Now here it wants a balanced symbol equation. Now it gives you the symbols for some of them, but not for all of them. So same process as with a word equation, draw an arrow first, and then it tells you that what is reacting together are these two. So you've got HNO3 plus NaOH, and that makes sodium nitrate, which is there, NaNO3, plus water. Now it hasn't given you the symbol for water, but you're expected to know that's H2O. Notice where I've put the numbers. They are slightly lower than letters, and make sure you copy these exactly, because that small a there is important. Capital letters only start the symbols, and that NA is one whole symbol, so the second letters of symbols are always lowercase. Now, in terms of balancing, there's a little trick here to see whether you need to put numbers in. If it's only worth 1 mark, then it'll already be balanced once you've written it out. If it's worth 2 marks, then it will need some numbers in order to balance it. So just look at the number of marks it's worth, and that'll tell you whether you need to actually check whether it's balanced or not. Next question. Alex reacts 4 grams of sodium hydroxide with 6.3 grams of nitric acid. He makes sodium nitrate and 1.8 grams of water. Use the principle of conservation of mass to calculate the mass of sodium nitrate that Alex made. So, essentially, the mass of stuff you start with will equal the mass of stuff you end up with. So what you've got to do first is work out how much you start with, which is 4 plus 6.3, which is 10.3, and then whatever is left from after the 1.8 grams of water, that'll be your sodium nitrate. So you do 10.3, take away 1.8, and that gives you 8.5, and that is the amount of sodium nitrate that's made. So the mass of everything at the end should equal, or will equal, because will equal the mass of the stuff at the beginning. Next question is the 6-mark question in the chemistry section. Again, just check using the mark scheme online, and again, if you're unsure, then ask your teacher. Next question, into the physics section. So there is a speed camera outside Rachel's school. The type of speed camera takes 2 photographs. Explain how these photographs can be used to check the speed of a car. So first thing is the idea that the photographs are taken a certain time apart. So there's a specific time apart which the photograph's taken, and then also the vehicle moves over a measured distance. And if you've got a distance and a time, then you can work out speed. So your first mark is saying that the photographs taken over a certain time. And the second mark is saying that the car moves a certain distance, which is measured. Rachel does her own measurements of vehicles as they pass the school. There's a result to calculate the speed of the vehicle which travels fastest past the school. So the idea here is that you'll probably need to work them all out just to make sure. So remember that speed equals distance divided by time. So here it's going to be 22 divided by 4 in the first one, which is 5.5. Second one is 44 divided by 7, which is 6.3 if you round it. Next one is 10 divided by 4, which is 2.5. Last one is 10 divided by 0.5, which is 20. So if you do that and just put 20, that'll get you all 3 marks. So remember that you need to, if you need an equation, then look it up in the front, and speed equals distance divided by time. Rachel rides a bike past the school at 11 metres per second, and the speed limit outside the school is 20 miles per hour. She wants to know if she's breaking the speed limit. So look at the graph, and the graph shows you speed in meters per second against speed in miles per hour. You can kind of convert using the graph. And it says, is Rachel breaking the 20 mile per hour speed limit? So if you look at 11 metres per second, you will see that it is actually beyond 20 miles per hour. It's around 24. But that doesn't get your mark. The mark is for saying that 11 meters per second equals around 24 miles per hour. So 11 meters per second equals 24 miles per hour, and that would get you the mark. So yes doesn't get your mark. You've got to explain it. Next question is a 6-mark question. As I've said before, mark it yourself using the mark scheme online. Then ask your teacher to check it if you're unsure. Next, scientists collect data on car safety. They perform test crashes with dummies in cars. They study the momentum in a collision. What measurements do scientists make to find the momentum of a dummy before the collision? So, to calculate momentum, momentum equals mass times velocity, which you can also look up in the front of the paper. So what you need is the mass of the dummy, and you need the speed of the car, or the dummy in fact, so speed of car. So both of those will allow you to work out the momentum. Scientists publish the data they collect on road safety. It is used by other scientists and car makers or manufacturers. Why might scientists use this data? So that's just to check it or retest the data. Or you could say that so they can do more research, or to check their own data, or the idea of improving safety. And what might car manufacturers use this data for? So that's making a car safer or to improve safety. Scientists have found that changes in momentum are the key to understanding the dangers of collisions. Explain how momentum is linked to injuries in a crash. So, first thing is that the change in momentum produces a force. And so, if you can, basically large changes in momentum produce larger forces, which give you greater injuries. So if you've got a big change of momentum, then that's going to make a bigger force, which will give you worse injuries. That'll get you 2 marks just for saying that. And then airbags are useful in a crash because they reduce injuries. Look at the information about 3 different airbags. There they are. Suggest which airbag is the best one to reduce injury and explain why. So 3 marks here. So you can say that A is the best one because it has a greater depth. And you could say, and it can change shape easily. And then both of those mean that A is better for absorbing energy. So you get 1 mark for saying it has a greater depth, 1 mark for saying that it can change shape easily. So that tells you it's got a greater depth there, it says to change shape easily, and 1 mark for saying therefore it can absorb energy easily. Last question. So Chris does an experiment with bouncing balls. He drops the first ball from 4 meters. What type of energy does the ball have when it is still at 4 meters high? So that is potential energy. And then what type of energy does it have when it falls? That's kinetic. So that's your special word for movement energy, but you can't say movement energy. You've got to use that keyword, kinetic energy. And then he then drops 2 balls of the same mass. He drops ball A from 12 meters and ball B from 6 meters. Both the balls bounce the same height, 4 meters. Compare the amounts of energy the balls have before they fall and after they have bounced. So here you've got to say that that ball A will have more potential energy because it is higher up. So there's your first mark. Ball A has more potential energy before it's been dropped, but it loses the most energy when it bounces because they both bounce the same height. So that's the end of the paper. Toss up your marks, write it on your poster, hopefully it's slightly more than last time, and move on to past paper 3.